Hello, my name is Lewis, and for this video I'm going to explain the results of the Nmap Network Intelligence Exam, specifically the second part of the test. I'm going to present the question and the possible answers that I have come up for that question. So let's start. The second question says, what kind of port scanning behavior constitutes an acceptable port scan etiquette? Of the scanning code that you have written above with Nmap, there are implementations that are less load imposing on subjects than others. Considering that a network application developer must conduct reconnaissance, which behaviors would you consider to be acceptable port scan etiquette? And in order to explain that, I'm using what is called the Nmap templates, that are basically different templates that have configurations predefined by default that we can use in order to put a higher load or less load in a network. In this case, the template 0, that is the paranoid scan, is a serial scan, which means that when a host is scanning a network device, in this case, for instance, a host B, it would be able to send only one data package at the time, and the maximum scan delay for that data package would be one second. So basically that means that we only be able to send one data package, and when that second happens, we can send another data package. And that is one of the reasons why the T0 paranoid scan is the less load imposing, because when you send a data package from host A to host B, it is going to wait even a maximum of 5 minutes before getting the answer of the receiver host. And in that, the host that perform the Nmap scan will be waiting at that time. I mean, a maximum of that time, which means that you are performing a very slow scan. So basically, it's a scan that is telling you that you can take your time in order to get an answer from a specific host. The second template is the T1, that is the sneaky scan, that is also a serial scan, which means again that it is going to send one data package at the time. However, the initial round trip time would be 15 seconds, which means that when you send a data package, it will be expecting an answer between 15 seconds, so it can send another data package. As you can see, that is faster than the first scan. However, you can consider that is still very slow compared to other type of templates. The third template is the T2, that is the polite scan or template, which has a default round trip time of 1 second. That is even less than the 15 seconds of the 5 minutes that are specified in the paranoid template and the sneaky template, which means that you will wait less time before sending another data package. And again, the number of data package that would be sent to the receiver would be one at the time. And in that category, from T0 to T2, you can say that if you have the scans that are less load imposing, because as you can see, you are only scanning one port at the time, and waiting, let's say, a considerable amount of time before sending another data package. However, things changes when you get to the T3 or normal scan. In this case, that is the template number 3, the normal template, the template number 4, the aggressive template, and the template number 5, the insane template. Sorry about that. In this case, the scans for those templates are performed in parallel, which means that we would be able to scan different ports at the same time, which means that those scans would be faster, and also would be putting a lot of more load in the network, because we can scan even 1000 port, 2000 port, or 110,000 ports at the same time, and you will be sending all that information between 1 second. So basically 1 second, 1 second, 1 second, and you will be sending a lot of data packages. And as you can see, depending of how high the template is, you will be waiting less time before sending that information. So basically the data rate would be higher, and when the data rate is high, you will have more load in the network. However, you have to know something important, that is that the higher the template is, more probabilities you have of getting results that are not accurate, because you are sending, in this case, if you take as an example the insane scan, you can send a scan that is going to get an answer about hundreds of ports, and you will be sending that information between 250 milliseconds. So basically that's very fast, and at some point the host that is receiving those data packages will not be able to acknowledge all those packages, and then send you an answer that tells you that the port was scanned, and in that process you will lose a lot of information. So basically, if you are scanning in order to detect 100 ports, you can get that the host B, the host that you are scanning, only have, for instance, 50 ports, when actually that host have 100 ports open. So basically the whole point of this slide is explained is that, as I said in the first video, the scan doesn't matter, because you can make a TCP scan that is very slow or very fast, depending of the options that you configure. So basically the scanning code doesn't matter in this case, because you can customize your scan. However, what changes everything are the templates or the options that you configure. Basically the templates are like a shorthand configuration that you can use in order to avoid writing all those options one by one. However, as I said before, you can configure them depending of your needs. So now let's start. For instance, I'm gonna write few scans so you can see how different they are, at least how much time they take. In this case, I have performed already a T3 scan that is the normal scan using the template number 3. In this case, it took almost, that's about 7 minutes or 8 minutes in order to scan a host. In this case, that host is my tablet that have an FTP port open in order to share files. However, let's start writing another scan. So let's say I'm going to customize the T5. In this case, that's an aggressive scan. I got the information that is that the TCP port 2121 is open in only 4 seconds. So sometimes you can get good results, however not all the time that would be the case. In this case, I'm sure that that's the only port that I have open in my tablet. However, when you perform a scan that is that fast, you are taking the risk of losing information, as I said before, because of the high data rate at which you are sending information, and the tablet or the host that you are scanning is not able to handle it. So now let's start the T4. As you can see, in this case it's different, since that scan is slower than the aggressive scan. As you can remember, the T5 was the insane scan, and the T4 was the aggressive scan, is slower than the T5. You can see that the information was even different. Now you can see that I have few ports that are filtered by a firewall. That is for instance the RSign service and the LAN desk service. Those are ports that we didn't get when we perform the T5 template, and that's what I was trying to explain before. If you are a network administrator and you want good results, a good idea would be performing a normal scan or a aggressive FCAM, depending of how fast your network is and depending of the specification of the devices that you are scanning. Because as you know, in an enterprise environment, sometimes you have machines or hosts that have good specifications, good network cards, or good network devices in general that are able to handle the different data rates. And that's why you must try to perform different type of scans in order to determine which one is the one that is good for your needs. And with that, I hope that you understand my point for the second part of the video. And if you have any question, as I said before, you can ask me, and I'll do my best to answer your questions. And again, thank you for listening.